2.4 continued. So today we are taking our fractional exponents, our radicals, and we're following our exponent rules. So again, I want to just touch on those very quickly and make sure you remember our exponent rules. If we have a base raised to, we'll say the m plus x, not plus, sorry, my bad, times by x to the n. If the bases are the same, you keep the base and you add the exponents. That's what we just did to get 7 to the 10 over 21, right? Okay. If I have x to the m divided by x to the n, then we subtract our exponents. Fine. That's fine. Okay, if I have an exponent raised to an exponent, we multiply our exponents. And of course, the one that's the hardest to remember for whatever reason, if I have x to a negative m, that means I move this to the bottom and m becomes positive. At the same time, if I have 1 over x to the negative m, that term is not happy where he is, so he would have to move to the top to become positive. Okay?
All right, Mr. Maker.
Thank you. All right, here we go. Example number 1. This is from the first section, so the 44 and 46. So let's say I have the 4th root of 18 times by the square root of 12. Right, so we can't multiply them together the way they are, right? However, if I write this as a fractional exponent, so I have 18 to the 1/4 times by 12 to the 1/2. Well, they're not the same right now, right? But I want to be able to put these together. So I need that one to be the same radical, which means I need a 4 on the bottom. Yeah, it's Remy. It would. So we're going to make this 2 over 4. So now,
Why couldn't you have just made that like with the 2 that started by the 12? You know what I mean? Like when it says 4 square root 18 times square root 12, why couldn't you just made it a 4 out there?
you can, but I'm showing you why it's that.
Oh,
Okay?
okay.
So really what we have here is we have the 4th root of 18 times the 4th root of 12 squared. So now if I'm multiplying 2 radicals together that are the same dimension, we multiply our outsides and we multiply our insides, right? So we have the 4th root. Now, if I multiply that together, it's going to be a huge number. So this is how I'm going to write it. I'm going to say I have 18 times 12 times 12. Because what do I have to do with these to simplify it? Exactly. So if I'm going to break them down anyway, right. So 18 is 9 times 2. 9 is 3 and 3. 12 is 2 and 6. 6 is 2 and 3. 12 is 2 and 6. 6 is 2 and 3. Now, in order to come out to the party, how many do I need? 4. All right. How many? Let's see. I have 1, 2, 3, 4 threes. Right? Here's 2 of them. 3. All right. I have 4 threes. So one group of 3s can come out. And I have a group of 2s that can come out. Yeah, so we get 6 Fourth root, what is the only thing left behind? A 1 singular 2, yes.
Wait, how'd you get the 6?
Because we had a group of 3s and a group of 2s.
Oh, okay.
So we multiplied them together. Okay? Let's try example number 2.
I did not like that. Yeah, I like that. Like, I'm not saying like it's hard, it's just like all the drawing stuff.
I know. All right, so this one's going to be a little bit different. All right, so in this one, can we reduce our fraction?
No, you cannot.
You cannot. They're different dimensions. So automatically, I want you to think, I need to change it to exponential form. I got to get an exponent. So this one, my x, is the power of 4 inside a square root. My y is a power of 1 inside a square root. On the bottom, my x is a power of 2 inside a 4th root. And my y is a power of 8 inside a 4th root. Any question with that step? Okay. So now let's simplify some of our exponents. Right? This one I have 4 divided by 2. So I just get 2. Y to the 1/2 I can't simplify. On the bottom I have x to the 2 over 4, which is 1/2. And I have y to the 2. Yeah. All right. So right now, let's talk about the top. This started off as a radical, so we got to go back to radical land. Okay? On the top, this one does not have a fractional exponent on it. So he is on the outside where he belongs. Okay? The y does, though. Power over root. So I have y to the first power inside a square root.
This class goes by so fast.
I know.
It's already almost 2:50. It only feels like 3.5 hours. I don't know.
Jackson!
I said the same thing yesterday.
I know. Okay. The bottom one. What's what's going outside and what's staying inside?
Wait, on the bottom right there?
Yeah, so
2 would stay on the outside and then the
yeah, so y squared doesn't have a fractional exponent, right? So he's good. The x, however, it's x to the first power inside a square root. Okay? So now, what do you see we don't like?
but how? Wait, no, the inside don't have to be.
Right? But we can't have a square root on the bottom, right? So we got
Square root on the. Oh yeah, never mind.
so we got a times by the square root of x. Whatever we do to the bottom, we have to do to the top. So we get x squared, square root xy over y squared, and the square root of x times the square root of x is just x. One last thing. What else do you see we can simplify there? The x's, right? I have x squared on the outside and x on the bottom. I get rid of this x for one of them here. So we get x square root xy over y squared. All right. Nope. Everything else is already set, right? The y on the bottom is on the outside where the other y is on the inside. Okay? All right. Example number 3, because that one was so much fun. We'll see. Example number 3. I'm hoping so. We're going to do the 48 through 54. Simplify. All of these, you can use your calculator to simplify. All right, so for example, if I give you -8 to the 2/3, grab your calculator. Well, you can just type it in, right? Parenthesis, -8 parenthesis, caret 2 divided by 3. 4. Correct. What if I gave you something crazy like 10,000 to the 2/3?
464.
Oh, wait. I meant 3/4. My bad.
750.
Nope.
250.
1,000.
There you go. 1,000 is correct.
We're just guessing.
Yeah. Because this is a 10,000 inside a 4th root, which is
Wait,
10, and it's raised to the 3rd power.
I got a question. Wait, why didn't you put the second one in the parentheses?
This one?
Yeah.
Because there's only one thing going on. This one is 2 because it's got a negative and an 8.
Oh, okay.
Yeah.
So like if I put that 10,000 in parentheses, it's still gonna be the same thing.
No, it's going to be the same thing.
It's just for a negative you have to put it.
What if you don't put it on the negative?
Because then it doesn't. Then you end up with a negative 4.
Oh, what did you say, Remy? You have blue balls up?
Okay, stop.
Balls.
Stop. Stop. All right. So are we good with the middle section?
Yeah.
Example number 4. The last section, you have to follow your exponent rules. All of them. Okay? So, for problems 56 through 66. This is the rest of it. We're following our exponent rules. So let's say I have x to the negative 4/7 raised to the 7th power. An exponent raised to an exponent, we multiply our exponents. So I have x. If I multiply my exponents, I get negative 4. Well, then if I have a negative exponent, where does that go?
On the bottom.
Right, so this is 1 over x to the 4th.
When you multiply, how is it just negative 4? They just cancel?
Yeah, when you multiply these two together, you can put it in your calculator, but the 7s end up canceling.
Wait, so there.
There's one on the top. Yeah,
Oh, could you do another one though?
yeah, yeah. Yeah. Patience. Patience. All right, let's do this one. What if I have x squared over x to the negative 11, all raised to the 1/3 power? So we're going to start inside. Where does x to the negative 11 need to go?
It needs to go in the bottom. But it's already there. Oh yeah, it is already there. So you gotta
Move it to where?
Top.
Move it to the top. So if I move it to the top, I'm going to get a total of x to the 13th. Because there's 2 there, I move 11 more. And it's raised to the 1/3 power. So then I multiply my exponents. I get x to the 13 over 3. This started off with fractional exponents, or it started off with exponents. So that's how we can leave it. Right, okay. Let's try example number 6. We'll make this the last one. Let's do it. Yeah, let's say I have x to the 1/2, y to the negative 2/3, and I'm going to raise it all to the negative 6.
Alright, so first we can probably start off with putting the negative at the bottom.
We can, or we can go,
Multiply.
yeah, let's multiply our exponents first.
I wasn't looking whenever you wrote it.
So this has to go to this one, and it has to go to this one. So I have x 1/2 times negative 6 is negative 3. Y, negative 2/3 times negative 6. A negative times a negative is a positive, and it is 4. So now Matt, what's the only thing that has to move? He's not happy where he is.
Negative 3 goes to the bottom.
Right, so I get y to the 4th over x to the 3rd. All right, you guys got this?